This is Tao Unbound, the English language podcast of Tel Aviv University. Please welcome your host, Ido Aharoni, Tel Aviv University's graduate, member of the Board of Governors, lecturer, writer, and veteran diplomat.
Welcome from Tel Aviv to yet another episode of Tao Unbound. I'm Ido Aharoni, your host, and today it is my great honor and privilege to host a superstar of Tel Aviv University, Professor Hadas Mamane. Welcome to our studio.
Thank you.
It's such a great pleasure to have you with us. We are eager to discuss with you your scientific work, which is about water and energy and waste and how to sanitize various locations in Asia and Africa and other places. But before we talk about that, let me tell our viewers and our listeners who we have in the studio with us today. So Professor Hadas Mamane, as I mentioned, is an academic superstar, and you can Google her up. And there's a lot of stuff about her work, and she is of great interest to global media. She's a professor at the School of Mechanical Engineering at the Faculty of Engineering, obviously at Tel Aviv University. She's also the head of the Environmental Engineering Program and the Water Energy Lab. We'll talk about the work of the lab with her. Also, she is the co-chair of the International Ultraviolet Association. She will explain what that means. She is the co-vice president of that association for Europe, the Middle East, and Africa. Africa is also one of the destinations where she conducts practical work. And she's also the chair of the same association, only at the United Nations Sustainable Development Goals Task Force. On top of all of it, she's the co-founder of Beyond Blue, which is an organization or an association devoted to increase the level of sanitation in various locales. Professor Mamane, wow, what an incredible CV you have. And we haven't even started going into the details. Before we jump into the subject matter, tell us, how did you discover your passion for science, and how did you discover that this is going to be your calling in life?
So I think it goes back. My father is a professor in also environmental engineering in air pollution. We come from a family. My parents, they lived in Morocco. They made Aliyah to Israel, and the entire life was kind of. I remember going with my father to the Technion, which is one of the technical universities in Israel, and I remember that I always wanted to be a student. I was going there, walking with the buildings. I was doing experiments during my when I was at high school, looking at the impact of sulfur dioxide on growth of plants. So I was connected to
every kid, every high school kid. That's what they do.
Yeah.
So wait, you grew up in Haifa then?
So I grew in many places in the world because my father is a professor. So I grew between the USA, Europe to Israel. So we practically lived every almost year or two in a different place in the world. So that was kind of my exposure to many places and cultures.
And were you able to follow your passion for science from one location to another?
Yeah. So I was kind of my dad's girl, and I would go with him to meetings, to the universities, to see labs and stuff like that. So I was exposed to all the environmental crisis and challenges very early on. But at high school, I wasn't that good of a student, and I never thought that I could be a professor. For me, it was something not achievable.
And you were already by then in Israel for high school?
So also that was between Israel, and also we lived also in Raleigh, North Carolina during high school. So it was between places. My father worked also at the EPA, Environmental Protection Agency. So it was, I was in many places.
Now, when your father, this is just out of curiosity, air pollution was a big issue in 1970s, 1980s, especially. Everybody remembers Los Angeles. It was infamous for that. So what was his research devoted to one specific area, or was it just a general type of research?
So it was on global air pollution. For example, he found that that particles from the Sahara Desert that contain sulfur can impact even like cars in Israel, for example. All the issue of transport of chemicals and particles. So it was like global work.
Which affects, obviously, what we breathe, affects cancer, and so on and so forth.
Yeah, he also worked on mercury in the Mediterranean. So all kinds of projects.
Wow, amazing. So you, in many ways, you are following your father's footsteps. Scientifically.
Yeah, I think so.
Because you're dealing with a different kind of pollution.
I know, but I never thought that it is achievable, that I could be a professor. This was something for me that only the greatest people can be a professor.
Well, apparently you can, and you did.
Yeah, it took me some time to believe in my capabilities.
So when did you discover the spark?
So I think that was after the Army, because at high school I had like difficulties in school. It wasn't easy for me. I remember that I went to the Army, but I wanted to do something significant. So then I studied for 1 year to be electrical technician. And that was like my position in the Army, fixing different communications and different cars, tanks, and stuff like that. And then I saw that I have technical capabilities, and that I can learn things and execute them, and I can even excel at what I'm doing, which for me was kind of a waking up that maybe I can do better than what I think I am. So I just remember that after the Army, I studied 1 year. It's something called mechina, where you like prepare yourself for the university.
Right. For our audience, mechina in Hebrew is a prep program for either university or even for the Army.
And then I saw that actually I'm really good in physics, mathematics, and chemistry. And I remember just being surprised, but I had the right teachers. And then I said, okay, maybe I can go to the Technion, where my father is a professor. And that's basically what I did.
So you pursued your first degree at the Technion?
Yeah.
And then?
I studied chemical engineering, but I had always the tension between academics and industry. I wasn't sure what I wanted to be. It was like kind of some people have like a very clear path. I knew that I wanted to be a professor, but I also wanted to, work in the industry. So I worked also in a paper mill. And I also worked in glass manufacture as a chemical engineer, as a process engineer. And in between these positions which I worked on, I saw that I can also lead projects. And so I decided to study master's in environmental engineering at the Technion. And then at some point, I decided that I will pursue my PhD.
And that was where, the PhD?
So I remember my father again told me, leave Israel. Don't stay here. Just go somewhere else, explore a different place in the world, and go do your PhD there. I contacted many professors at the U.S. and I found one professor, which his name is Professor Carl Linden. He was back then at Duke University. Now he is at Boulder. And I just remember fascinated by his research, and I got accepted to Duke. So I left everything and pursued my PhD for 4 years at Duke University.
So you became a Blue Devil.
Yeah.
and do you follow their sporting teams?
Definitely. You can't be a Duke and not do that. Yeah. Yeah, that's impossible. I remember I was even going to the camps, not sleeping at night and all this stuff to get tickets to the games. Yeah, for sure.
Amazing. Well, that's an experience. So just for the benefit of our audience, so people understand what is chemistry. People may understand what engineering is all about, but what is chemical engineering?
So I'll try to make it simple. If a chemist takes, for example, a compound, like I would say, like a solution that is called A and B, and mix them together, and they get a solution or something that is C. Okay, the A and B reacts with each other. Okay, but that's in small amounts. But a chemical engineer would take this reaction to industrial scale. For example, let's assume that A and B, when they react together, they release heat. But if it's on a small scale, who cares? But when you try to design a manufacture line and it releases heat, you need to consider that in the materials that you choose. You need to maybe have a heat exchanger. You need to develop the process so it can scale up. So chemical engineers are actually not that great in chemistry, but they know how to take chemical reactions and develop a full process, develop the reactors that we should use and stuff like that. So that is a chemical engineer.
Right. So the equivalent would be in real life. When you build a little house out of Lego, you don't need a building engineer. But when you actually build a big building with hundreds of units, you do need an engineer.
Exactly, yeah.
Because the same principles all of a sudden have a different scale, and someone needs to calculate the meaning and the implications.
Exactly.
Got it.
All the
That's a
thermodynamics, heat transfer, mass transfer, all these issues we need to consider on large scale.
Right. So that's a beautiful way of putting it. Thank you. Thank you for clarifying this issue. Now, what I would like to do is touch upon two issues that this is your expertise. The first is water. Second is waste. And then we'll talk about your lab. But first, let's start with describing the scope and the magnitude of the problem, because we live in Israel and we have the luxury of access to water. We can actually drink the water, tap water, right?
And I'll show you an example.
And right here, this is tap water, Israeli tap water. Delicious. And so, but that's not the case in other places. I know you've done a lot of research in Africa and in India. Tell us what's happening in those countries, in those places.
Yeah, but like if it's okay, I would like to just go a bit back when I knew that I want to work on water. I remember I had a class and where the lecturer saw a fish dying in a water body because of contamination in the water. And I remember myself at that moment, I actually started to cry, which I remember in class, which was like kind of weird, but I felt kind of like association with like the living entities. Like I felt that I need to do something about it. I can't like live my life and let these things happen. So then it kind of like clicked to me that water is something that I really want to give my life to. I want to do something in water. And I think that's where it kind of started, where I really wanted to focus on water. But if we look at low-income countries...
Right, by the way, in Hebrew, there's a term from the Jewish tradition, Maim Chaim, meaning water is life. It's the source of life, right?
Yeah.
Maim Chaim.
Yeah.
Right? Water is life, or living water.
Yes.
So you said water is my calling in life because I can save lives.
Yeah. Exactly. That was the thing that kind of triggered my passion. I knew that I wanted to do something with water. I wasn't aware of the magnitude of the problem back then. And like I remember as an engineer, you are actually educated to solve to provide a solution to a problem. But you don't think about, like, for example, like humans or people or environment and stuff like that. It's like very, as an engineer, you have a problem A, you find a solution B, and that's it. Of course, it would be implemented, it would be integrated, people will use it. There's no reason. If there's a technical advantage, then that's it. And I came with this mindset to the water. I said, okay, like if there's like coliforms in water or pathogens, which are microbes that result in disease, we can disinfect the water and we can solve the problems of the world easy enough. And when you take contaminated water to the lab and you treat it, you get good results and you say, okay, so what's the problem? Why are people still dying? Why is why is diarrhea affecting like so many kids around the world, and actually is the second cause for children dying
And what is
due
the
to
answer?
contaminated water.
And what is the answer to that?
So this is like really puzzling because like we have all the technologies, but the problem is to actually integrate the technology in different communities, and that is like a real issue and a problem, because you need the supply chain, you need the cost to be low enough, you need to have governmental support. And also people have the realization that for energy they would pay, or for their cell phone they would purchase. But clean water is very expensive actually. Water does not come clean naturally, definitely not today. And in order to have safe water, you need to actually invest in it.
Right.
And people don't understand this. And then you have also the distribution systems, and so it's a very complex. It's a complex problem.
And I'm assuming, not that this is in the purview of an engineer, but there's also a cultural barrier, right? Not every culture is willing to go the extra mile. It's not part of the culture sometimes.
Yeah, it's also an issue, definitely.
For example, you talk about waste. I remember I had a guest here, Professor Alon Tal, and we had a discussion about why the Israelis are not taking care of public places in terms of waste, and he said you'd be surprised. It's a global phenomenon. It's not just an Israeli issue, and it's true. So tell us about so you came with this holistic approach. You said, okay, it's not just about finding a solution to a certain microbe that is in a certain lake in Africa.
Yeah.
There must be a systemic solution, a holistic solution. And so what was the scope of the problem that you discovered? So you mentioned diarrhea as a cause of death among children. What else have you discovered?
So it's also chemical contaminants in water, heavy metals. There is such a huge range of contaminants in water, and some of the contaminants actually result in long-term impacts. Others are immediate impacts. So then, like, you need to like map what do you need to do, and it's really difficult to understand where do you need to focus your work on, because there's so many problems, so many issues, so many types of contaminants. Like, how can you actually make a difference? And this was something that I was, it wasn't that clear to me. What can I do to make a difference? Because it is my call, it is my passion, and then it's very complex, because also air pollution impacts water quality. Waste also, and the problems are interconnected in some way. We know that we have floods, also water get contaminated, but floods are also an impact of climatic issues and problems. So it is a huge problem, and then kind of like you get lost in some way. Like, where would you go? What would you do? And this is something that I'm still trying to figure out.
Trying to figure out where you could have the most impact.
Yeah.
Right. And and I know you started with some projects in India. I would love to hear some more about those projects, and then I would like to switch to your work on waste.
Okay. So in India, I'm doing like many things. One of them is working on sewage ponds. Basically, many villages in India, they have a pond where the sewage actually flows into, and the water is sometimes used for agriculture irrigation, sometimes not. It depends on the availability of the groundwater. But anyway, we're working on finding low-cost solutions to treat sewage in rural areas. So this is one project that we're focusing on together with Tel Aviv University and many partners. It's like huge scale, I would say, issues.
And in some rural areas, there is no adequate infrastructure, right?
No,
so people don't even have the facilities at home.
Right. So most of the rural areas do not have infrastructure to treat the sewage. And sewage is sometimes something that is not spoken enough about. People talk a lot about water, but not about sewage. But actually, sewage and runoff from agriculture contaminates the water sources. So everything is interconnected. And if you want to have safe water, you need to treat the sewage. You need to avoid overuse of fertilizers in agriculture. And it's such a connected problem, an interconnected issue, where you can't only deal with one part of the picture, which makes it very, very complex. In addition to that, together with IT Madras, we're working on a project that is called People's Water Data. That is a huge problem. We also have a website of People's Water Data, so everyone can open and read about it. Basically, we already analyzed 10,000 water samples. And this project is actually, our goal there is to understand where are the issues or the problems with drinking water at the household level. So we're also doing that. And we also have disinfection projects. And also we're working a lot in Uganda together with an NGO that is called Innovation Africa, also working on providing disinfection solutions in rural areas in Uganda.
Yeah,
and our goal is actually to implement these solutions more. I'm also part of the IUVA organization, which we provide UV-based solutions to water disinfection, which I remember, if we go back, it's the second leading cause of diarrhea. And actually, UV can disinfect all those organisms and provide safe water without using chemicals.
Wonderful. And tell us a little bit about the work of the lab, because we're kind of limited in time. I wish I could go and ask you about all those amazing things that you're doing. But the Water Energy Lab, tell us about that lab.
Okay, so our lab is a diverse lab. People, I think the most important thing for me is that my students, the PhD postdocs, master students will really, I don't know how to say it, but I want them to be happy when they come to the lab. I want them to be passionate about what they're doing. So for me, it's not only grades. It's like the approach of the student when they do the research. I want them to work together. And I also really, I would say, try to think about innovation and novelty and how we can implement things in the field. And so, for example, now we developed like a process where we're starting a startup company on actually extracting lithium from brines. And that can provide a solution for also for lithium batteries. We're doing all kinds of projects in water, in energy, and so that's kind of where we try to develop the lab in various places.
Let me ask you before we wrap this up. Our audience is friends of the university for the most part, people that care deeply about the success of the university and its scientists, like people like yourself. What are your most pressing needs when you're looking at the work that is being done at the Water Energy Lab right now at Tel Aviv U?
So I think most of the projects are supported well. I think the only thing that, for me, that I'm really passionate about, but this is something that I'm a co-founder of an NGO that is called Beyond Blue. And we're passionate about supporting UV LED projects in India and Africa. And this is something that actually is more humanitarian, and I think it's very difficult to fund such projects. I think this is the thing that I would love to advance more, because we have a lot of knowledge and a lot of experience, and we would love to provide safe water. I think that is like the thing.
Well, I think you made a pretty strong case about the importance of clear and safe water, and because it affects almost every aspect of our lives, from medicine all the way to agriculture and the food that we eat and so on. Well, this has been a fascinating conversation.
Thank you.
Professor Hadas Mamane of Tel Aviv University, thank you for educating us about the most important and most pressing matter. And hopefully we'll get a chance to host you again here at the university to talk about the next phase of your great work.
Thank you very much.
Good luck in the future. And to our audience at home, from our studio in Tel Aviv, goodbye until our next episode.